Welcome to our comprehensive React interview questions series. Today, we'll explore the essential topics you need to master for React interviews, including hooks, state management, and performance optimization. React has three core areas that interviewers focus on. First, React hooks. These include useState, useEffect, and other built-in hooks that add state and lifecycle features to functional components. Second, state management, covering both the Context API for simple global state sharing and Redux for complex application state management. Third, performance optimization techniques like memoization, code splitting, and testing strategies that ensure your React applications run efficiently. This series is part of our Frontend Frameworks collection, designed to make you interview-ready. The useState hook is React's primary method for adding state to functional components. State in React refers to data that can change over time and affects how components render. The useState hook returns an array with two elements, the current state value, and a setter function to update that state. When state updates, React automatically re-renders the component to reflect the changes. The hook also preserves state between renders, meaning your data persists even when the component re-renders. In our counter example, we import useState from React, initialize it with 0 as the starting value, and destructure it into count and setCount. The buttons on click handler calls setCount with the new value, triggering a re-render with the updated count displayed. The useEffect hook manages side effects in React functional components. Side effects include data fetching, subscriptions, timers, or manually updating the DOM. The hook accepts a callback function and an optional dependency array. When called without dependencies, useEffect runs after every render. With an empty dependency array, it runs only once when the component mounts, similar to component did mount in class components. With specific dependencies, it runs when those dependencies change. The dependency array is crucial for performance. It tells React when to rerun the effect. In our data fetching example, we fetch user data when the user ID prop changes, ensuring we always display the correct user information. The Context API solves the prop drilling problem in React applications. Prop drilling occurs when you pass props through multiple component layers just to reach a deeply nested child component. Context provides a way to share data across the entire component tree without explicitly passing props at every level. To use context, you first create a context using createContext from React. Then wrap your components with a provider component that supplies the shared data. Any child component can access this data using the useContext hook. Context is perfect for global state like user authentication, theme preferences, or language settings. However, be mindful that context changes cause all consuming components to re-render, so use it judiciously for frequently changing data. Redux is a predictable state container that follows a unidirectional data flow pattern. The Redux flow has three main steps. First, an action is dispatched. Actions are plain JavaScript objects that describe what happened in your application. Second, the reducer updates the state. Reducers are pure functions that take the current state and an action, then return a new state. Third, the store notifies all subscribed components about the state change. This predictable flow makes debugging easier and enables powerful developer tools like time travel debugging. Redux is particularly useful for complex applications with multiple components that need to share state, or when you need to persist state across page refreshes. The centralized store makes state management more organized and maintainable. React Redux provides two essential hooks that simplify connecting React components to the Redux store. The useSelector hook extracts data from the Redux store state. It accepts a selector function that receives the entire store state and returns the specific piece of state your component needs. The useDispatch hook returns the dispatch function, allowing you to trigger actions from your components. These hooks replace the older connect higher-order component pattern, making Redux integration more straightforward and functional. When you call dispatch with an action, Redux runs your reducers to update the state, and any components using useSelector automatically re-render if their selected data changes. This reactive pattern ensures your UI stays in sync with your application state. React functional components have three main lifecycle phases that you can manage with the useEffect hook. The mount phase occurs when a component first renders. Use useEffect with an empty dependency array to run code only on mount perfect for initial data fetching or setting up subscriptions. The update phase happens when component props or state change. Use useEffect with specific dependencies to run code when certain values change. The cleanup phase occurs when a component unmounts or before an effect reruns. Return a cleanup function from useEffect to remove event listeners, cancel network requests, or clear timers. This prevents memory leaks and unwanted side effects. Our timer example demonstrates all three phases, setting up the interval on mount, updating the display on each tick, and clearing the interval on cleanup. React provides two key memoization techniques to optimize performance. React.Memo is a higher-order component that prevents unnecessary re-renders when a component's props haven't changed. Wrap your component with React.Memo to enable this optimization. It performs a shallow comparison of props and only re-renders when they actually change. The useMemo hook caches expensive calculations between renders. It accepts a function and a dependency array, recomputing the cached value only when dependencies change. useMemo is perfect for expensive operations like filtering large arrays or complex mathematical calculations. Both techniques help reduce unnecessary work, leading to smoother user interfaces and better performance, especially in large applications with deep component trees. The useCallback hook memoizes functions to prevent their recreation on every render. When you pass a function as a prop to a child component wrapped with React.Memo, the child will re-render if the function is recreated each time, even if its logic hasn't changed. useCallback solves this by maintaining referential equality. The same function reference is returned unless dependencies change. This optimization is particularly important when passing event handlers to optimize child components or when functions are used as dependencies in other hooks. The hook accepts a callback function and a dependency array, similar to useEffect. Only recreate the function when the dependencies actually change, ensuring your performance optimizations work as expected. Testing React applications involves two main tools and approaches. Jest is the JavaScript testing framework that provides test runners, assertion functions, and mocking capabilities. React Testing Library offers utilities for testing React components by focusing on user interactions rather than implementation details. This approach makes tests more maintainable and reliable. Write tests that verify component behavior from a user's perspective. Test what users see and do, not internal component state or methods. React Testing Library encourages best practices like finding elements by their accessible names and simulating real user interactions. This testing philosophy leads to more confident deployments and easier refactoring, since tests focus on the component's public interface rather than its internal implementation. Effective React testing follows three key principles. First, test behavior, not implementation. Focus on what your component does rather than how it does it. This makes tests less brittle and more valuable for catching actual bugs. Second, follow the arrange act assert pattern. Set up your test data and render components in the arrange phase, perform user interactions in the act phase, then verify the expected outcomes in the assert phase. This structure makes tests readable and maintainable. Third, focus on integration over unit tests. Test how components work together rather than testing every function in isolation. Integration tests provide more confidence that your application works correctly while being less sensitive to implementation changes. These practices result in a robust test suite that catches bugs while remaining maintainable. Congratulations! You've now covered the essential React concepts for technical interviews. Let's recap the key areas. Hooks are the foundation of modern React. Master useState and useEffect for basic functionality, Then learn useCallback and useMemo for performance optimization. State management starts with local component state and context API for simple global state, then progresses to Redux for complex applications with predictable state updates. Performance optimization involves memoization techniques, lifecycle management, and understanding when and how to prevent unnecessary re-renders. Testing ensures your applications are reliable. Combine Jest and React Testing Library to write meaningful tests that verify user-facing behavior. With these fundamentals mastered, you're well prepared for React interviews and ready to build amazing, performant applications. Continue practicing these concepts and applying them in real projects to solidify your understanding.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.